Have you ever stood in front of your class and asked a great inquiry question only to be met with complete crickets? Because I know I've been there. A number of years ago, I watched Dan Meyer's Math Class Needs a Makeover, and if you haven't watched it, I highly recommend it. I was on fire to get my kids thinking, and I remember I wrote all my questions and I started with the end, but my students gave up and they just wanted me to give them the steps. Hi, I'm Jennifer with Solvefinity, and as a secondary math teacher and a math coach for more than 25 years, I've seen this play out time and time again across grade levels. So if you also want to try inquiry learning, but you find your students are stuck, it isn't the kids and it isn't your questions, it's just that you are missing the same roadmap that I was. Today, I'm going to show you how to move beyond the steps and make inquiry a normal, modeled part of every class, even for the dry problems with no context. You aren't just teaching math, you're teaching the thinking skills the students need to be able to tackle the messiest math problems in life and on those high stakes state assessments.
So what exactly is inquiry-based learning anyway? Inquiry-based math is when students are asked to make sense of a situation before they're taught a method. They need to ask questions to get the information that they need. Take a look at this museum scenario. Now, normally we would give the students all of the measurements and ask them what is the angle of the light shining down on the statue. Now, if this isn't the kind of math that you teach, that's fine. We're not doing any calculations today. We want the students to ask questions like how far away the statue is from the wall, how tall the spotlight is, and how tall the pedestal is. There's even room to discuss how far up the statue the light goes. That's where most teacher professional learning leaves off. How do you actually get the students to ask the questions? Inquiry-based math is based on what is my goal, what do I need to know, what do I already know, and how will that help me? You need to facilitate these questions in every discussion, even if there is no context to the problem. If I gave you a quadratic equation and asked you to graph it, you might wonder what a quadratic equation is. The power of inquiry-based math is that we're front-loading the thinking. What if I say I have the graph of a quadratic function, what is the equation, and give you no other information? That seems totally unfair, right? That's why most teachers give up at this point with inquiry-based learning. The students don't know what to do, so the teacher over-scaffolds and does the thinking for them. The student waits with their head down or plays on their cell phone until somebody gives the right answer and explains how they did it. The missing piece is scaffolding the inquiry itself. Once the students are proficient with it, you can scaffold with things like diagrams that give them little hints about the types of things they can ask for. To get to that point, I like to start with what I call inquiry maps. It's a way of taking notes where students list the questions that they could possibly ask, what that information is going to tell them, and an explanation of how to use it. You can differentiate for your class by deciding how much information to give them versus how much they have to fill in. It is also giving your multilingual learners the language that they need to ask the questions. I have more information about inquiry maps on my blog, and the link is down below. I did this example with rational graphing in a mixed group of teachers who taught all different grade levels. Some didn't know how to graph a rational function at all, and we looked at a traditional set of notes that were step 1, step 2, step 3, and most of them were still just as confused. But then I gave them a fully filled out inquiry map. And don't worry if you can't read it on the screen, I have a copy on the blog as well. Then my upper level teachers were given this set of questions that they could ask me. And some of them didn't even need this much scaffolding. So one of them asked me, are there any holes? And I said yes, at x equals 3. I then asked the very important follow-up question, how is that going to help you? And they explained that they knew that if there is a hole at x equals 3, then x minus 3 must be a factor in both the numerator and denominator. And if you don't want to give that much information away, just like in the illustrative math infogap questions, you can ask, why do you want to know that? And they can just explain how they will use it, but not quite what it's going to give them as the answer. For context problems, let's do that old teacher favorite, how many bacteria in a dish? So if we have students that are used to thinking this way and we present them with a more traditional word problem, what we want them to do is immediately think they need to know how many bacteria there are after 9 hours. So I can ask myself, how many were there at the start, and go back and look for that in the problem. Inquiry models the metacognition we want them to have. Now, as promised, this can be done with any level. Take this as a typical sort of state assessment question. We want our students who are used to thinking this way to focus on just the question. This is a circumference question, so I'm probably going to need the radius. I wonder if I can find it in the problem. Then how much is the fencing? With anything, it takes practice, but the more you do it in class, the better they'll be able to do it on their own.
Just remember that inquiry doesn't have to be some separate special lesson that we just hope doesn't flop. It's the engine that drives every class every single day. When we model the questions we want our students to ask themselves, we're giving them the tools they need to navigate any problem from kindergarten through calculus and beyond. So if you want to try this in your own classroom, I've put a link to my Solvefinity website with some inquiry templates in the description below. Grab it, make it messy, and let's get our students talking again. Thanks so much.